Hey everybody, so in this video I'm going to kind of give a little overview on how we would use a reference spectra in G4 to exclude certain frequencies from an event. So let's say that you are trying to do a spectral analysis of a device or something, and you would like to have an event trigger when certain frequencies go over a certain amount. Well, what if there's a specific frequency, maybe it's a 60 hertz hum or something like that, that you do not want to act as a trigger for your measurement? We can essentially eliminate this using the octave band filters present in your 831C if you have the octave band firmware installed. So as you can see here, I've got G4 open on my computer. I've got my 831C connected, and I'm looking at the live view right now. So the first thing that I'm going to do is show you how to set a reference spectra. I'm just going to go down here to the octave bands here. So this is the octave band analyzer, the real time. It does everything in real time. Right now I have it set to third octave bands. So you can see all the different frequencies here. You can use your keyboard or your soft keys to go over and see different frequencies. But what we're going to do is we're going to set a reference spectra. So to do that, we hit the hamburger stack up here, and we're going to go to System Properties, and we're going to navigate over here to Reference Spectra. So in our example, we're trying to exclude a 60 hertz hum from our measurement, and the best way to do that would be to use the third octave bands. I've already made one here called 63 hertz filter, but I can go through and show you what that process looks like. So essentially you can let me see here, this one already has stuff in it. Okay, so filter 4, so you can have up to 4 user-defined filters here for each band. Filter 4 here is just a default. There's absolutely no weighting here or anything. Everything's just a 0. So that's what you would be presented with if you don't have any data in here yet. So I'm going to jump up to my 63 hertz filter that I've already made. And in my example, I want the trigger level to be 80 decibels. And to do that, you essentially set each frequency band to 80 decibels, because we're trying, in this example, what we're trying to do is we're saying, okay, if any one of these frequencies right here is over 80 decibels, that we want an event to trigger, except this 63 hertz band, which would be comprised of some of that 60 hertz hum that we are trying to eliminate from our triggering. So what you would do is you could just put in 80 here for all these values, or whatever trigger level you want. Now in this example, I'm just trying to make it a baseline trigger of 80 decibels. We can get into something a little bit more advanced here shortly, but for right now we're just putting in the value that we want each frequency to be at. So I'm making it very simple. So we would put 80 decibels in for all of these, except the 63 hertz. So what I'm doing here is I'm saying, okay, well, I'm going to bump this up to 140 decibels. So the program has limits to how high and low of values you can put in here. But essentially, I don't think it'll let you go above 140. But what we're really saying here is, okay, I need this specific 63 hertz band to be very, very loud relative to all these other bands for it to activate the trigger. So, but we just want to set this to a very high value that we would not expect to see in practice. So we're just trying to make this much higher than these other ones here, which is why that's set at 140. So now, why did I use a 63 hertz band? I thought we wanted to eliminate 60 hertz. Well, we don't have an octave band for 60 hertz. So I'm going to use the 63 hertz band because its center frequency of 63 hertz is closest to the target frequency that we're trying to eliminate, which in this case is 60 hertz. So that's why I have this set here. So you can see all these other values are set to 80. So this is our reference spectrum here. And we just note that this is reference Spectra 1, even though I've called it 63 hertz filter. And if you want to see what how you do this, you just highlight it and you just put an 80 here. And then you just kind of go through like that. So that's how you would change these values. Very simple. You just use your keyboard, or you can do it on the meter. And once you're done, you just hit close, and you want to save your settings, and that's that. So, okay, now that's all great. We have our reference spectrum. So how do we actually make this trigger? Well, we're going to go to the setup manager, and I have the default setup here activated. So I'm just going to go set that to make active. And then we're going to go through here and change things to be what we would need for this specific configuration. So I'm going to name my data file something from the default. I'm just going to call it 63 hertz score FLTR, or FLT because we're out of characters. I'm going to then go over to this tab here. We're going to want these to be Z weighted. I'm going to put the detector on fast, and our peak weighting is also going to be Z. We have to make sure our octave bands are on. I'm having them set to the normal range. Of course, this setting here essentially depends upon the range of the sound pressure that you're trying to measure. So if you need to measure something that would be more in this range, then you could use the high range, or for our case, 26 to 111 decibels is well within the range of what we're measuring. So I'm just going to put that on normal. I'm going to be using the third octave and Z weighting. So I'm just going to come over here. This we're not going to touch. I'm going to leave this on manual run stop mode. So we're going to use the run key and the stop key to initiate our measurements. Now, one thing that we are going to have to do is we're going to have to enable time history. That's going to allow us to see the data that we record. So I'm going to select, well, let's just do 10 milliseconds of time history. And let's not do that. That's too, that'll get rid of something. So we're going to go 20 milliseconds. I just want my peak values here, my equivalent values. And then I'm going to get these for the octave band values right here. If we want more information, we can always bump this up to like 100 milliseconds. Then you see we have more options that become available. So really just kind of a trade-off between granularity and how many things you want to log. So I guess for this we'll just do 100 milliseconds. So now I'm going to go over to our triggers. We're not going to be using this. We're going to be using this event history function. So I'm going to make sure I turn the event history on. Now this is minimum and continuation. So this basically means, okay, our event is going to have to last for a minimum of, we'll just call it 0.1 seconds, and it can last up to and it can go up to 2 seconds before, well, let me back up. So an event has to occur for at least 0.1 seconds for it to be considered an event. So our trigger has to exceed 80 decibels, and it can dip below that trigger, it can dip below that 80 decibels for up to 2 seconds before it is labeled as a new event. So that's what this minimum and continuation means here. So we're going to trigger with a level. I'm going to turn on the event time history. I'm going to set this to samples of 100 milliseconds. And I'm going to use the spectral mode because I want to see the spectrum that I'm recording, our octave bands. So I'm going to go to event trigger. So what we're going to use is I'm going to do LZ. Where is it? LZEQ. I'm not going to use this. We don't need that. So we're just looking at LZEQ, and we want that to be at 80. Now we come down here to the octave band that we want to use. And remember before how I said we should make note of which spectrum that we customize? Well, our 63 hertz filter was in the first spectrum of the 1/3 octave filter. So we're going to select that. Now this any and all option here basically means, okay, so right now it's set to all. So that means all frequencies in our octave band must exceed the trigger level for an event to happen. For this type of test, I don't think that's what we want. We're probably just looking for a few individual frequency bands to go above that limit. So I'm just going to set this to any, which this means that if any single one of those frequency bands, and remember there's, I believe, 36 of those for 3rd octave, so any one of those that goes above our trigger level will create an event. So that matches what I want to do, so I'm just going to set this to any. Markers, we're not doing any of this. We're not doing sound, weather. So I'm going to save my settings now. So I'm just going to call this 63 hertz filter. I'm just going to call this 63 hertz filter. And there you go. Now that is saved, and that is now the active file. So we can go ahead and close out of this, and we can go down here and look at our normalized octave data. We're using reference of the 63 hertz filter here. So I'll clap my hands like that, and we'll see that we have something that triggers above that. So I will go ahead and start a run here. Okay, so now we're going to see what this looks like when we run our measurement. So I'm going to come up here, I'm going to click run, and you'll notice here, so it's ready. I'm just going to tap the microphone. Okay. And you see that recorded an event right there. So that's basically what this looks like. We can go down here to our live view, and we can see our reference spectrum here. I'm just going to blow in the microphone. See, any one of those events there would trigger if they go above, but notice how this 63 hertz band here is not being really activated when I blow into the microphone. So you can see there nearly every single frequency would have triggered it, but this 63 hertz. So that kind of gives you an idea of how this is intended to work. So there's another thing that we can do to change we can set a reference spectra. So I'm going to go and use number 2 slot here. And what this would be for is, okay, so I want to find, let's just say I'm trying to measure a machine or something, and each frequency level does not have a uniform trigger level because it's a dynamic machine. So what we're going to do is we can make a reference spectra tailored specifically to the device or whatever that we're trying to measure. So I'm going to hit set reference. Okay, so now what this is essentially has done is it's normalized the frequency spectrum to what it just listened to here. So I'll be quiet. And we can see that that's kind of our baseline. So anything above this baseline would be a trigger. So let's just say we wanted to do the same logic and we wanted to make this our trigger level. Well, what we would do then is go back into the system properties and we would go over here to where is it? Reference spectra. So we're going to do spectrum 2 this time. That's the spectrum that we just took a snapshot of. And so let's just say, okay, maybe these are our new trigger levels. So anything that goes above this is what we want to have a trigger. However, we still want to eliminate our 63 hertz. So I'll put 140 in for that. And now you can see that that value is much higher. So I can hit close, save, and then close this again. Come on, close. Now here's that same spectra because we're still looking at the same reference, except I added this trigger to be lower to be higher at 63 hertz. So, you know, all of this, that would trigger it, but let's just say there was a spike in the 63 hertz band. That's not going to trigger it unless it's very, 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 very loud. So that is really our desired response. And we can go into the setup manager and we could use that spectrum instead. So I'm just going to go here, set this to active, because remember we chose a spectrum. We chose spectrum 1 to be active. Well, that's no longer the case because we just changed to spectrum 2. Where is it? And that would be the spectrum that we want to use instead with the more dynamic triggering. So we're going to leave this at any, and I'm going to hit close. I'm going to save and close, and we're going to go back to the live view here. So now we're going off of this normalized spectrum that we made using our real-time recording of the device. So the procedure for recording and all that is the same. It will trigger events based on any of these rising above the trigger level. Now, it might be a good idea to, in your reference spectra, if you take a dynamic spectrum like this, is to set each of the trigger levels maybe just a little bit higher than the default background noise. So maybe you'd want to bump these up each by like say 3 or 5 decibels or something like that. And so you still have that shape, but maybe you just want your triggering to be a little bit higher so it's not triggering all the time. But hopefully that gives you a pretty good idea of how to use this feature. And of course, if you have any questions, you can always reach out to Larson Davis and somebody will assist you. Thank you very much for watching, and I hope you have a great day.